Okay, now we're going to be focusing on math check-in number 8. In a 5th grade class, 3/4 of the students like to go to the movies. Of the students who like to go to the movies, 2/3 of them like action movies. Of the students who like to go to action movies, 4/5 of them also like comedies. What fraction of the students in the class like to go to action movies? And so the first thing we're going to be looking for are the action movies. So we're going to take this sentence right here and turn it into a mathematical equation, because they already, in essence, told us what the answer is. They're asking for what fraction of the students in the class like to go to the movies, and this statement pretty much says it. Of the students who like to go to the movies, 2/3 of them like action movies. So if we convert this sentence into mathematical terms, we'll be all set to go. When they're saying them, they're referring to the students who like to go to the movies. So keep in mind, because they're going to use the word them here also, but it's going to mean something different. This time, of the students who like to go to the movie, 2/3 of them. They're referring to the students that like to go to the movies. So, how many students like to go to the movies? Well, if we read the first sentence again, in a 5th grade class, 3/4 of the students like to go to the movies. So, this of the students who like to go to the movies is 3/4. And when they're referring to them, they're saying 3/4. Of means multiply. So for the first one, in order to find the action movies, 2/3 of those 3/4 that like to go to the movies like action movies. So you're going to do 2/3 of means multiply. Them is referring to the 3/4. Now once you solve this, you'll find the right answer. You just do the numerator times the numerator. 2 times 3 is 6. Then the denominator times the denominator. 3 times 4 is 12. And from there you could simplify. You could ask yourself what number can go into both 6 and 12 in order to reduce. 6 divided by 6 equals 1, and 12 divided by 6 equals 2. So your final answer is 1/2 of the students, 1/2. Another way to have done that, if you want, is to think 2/3 times 3/4, and you could simplify way at the beginning. Actually, I'm not going to. Actually, a second ago I was going to do something else, but it might confuse you. Just for those that like to simplify ahead of time, the 3 could turn into 1, and this 3 would turn into 1, and this 2 would turn into 1, and this 4 would turn into 2. For those that understand it, you can use that as a shortcut, but I'm not going to go into depth and confuse other people. Alright. Now we're going to look at the second part of it. What fraction of the students in the class like to go to the action movies and comedies? Explain how you found your answer. Here's where you look at the second part. Of the students who like to go to action movies, 4/5 of them also like comedies. So here we're trying to see who likes both comedies and action movies, but of the students who like to go to the action movies is the new them. So we're not going to use 3/4 like we did last time they said them. Instead, it's how many people like to go to the action movies. Now, the people that like to go to the action movies, we found out in part A. So, the amount of people that like to go to the action movies is 1/2. So that's who likes to go to the action movies. When they're referring to them, they're referring to the action movies. So you're talking about 4/5 of 1/2. Of means multiply. So your new equation for part B is 4/5 of, which means multiply, 1/2. And again, you could do numerator times the numerator is 4. Denominator times the denominator is 10. And if you simplify by 2 over 2, 4 divided by 2 is 2. 10 divided by 2 is 5. You'll get your answer of 2/5. So, the answer for 1/2 and 2/5, you can now explain in words down here how we solve that. And I'll let you do that one on your own. Now we're on number 2. Hannah is tiling a section of her bathroom wall with tiles that are 1/2 foot by 1/2 foot. The section of the wall is 2.5 feet tall and 4.5 feet wide. Let each square on the grid represent 1/2 foot by 1/2 foot. Draw a rectangle on the grid to represent the section of the wall. So this is what we were talking about in one of the previous lessons, where one square is going to represent 1/2 because that's what the directions said it would do. Each square is 1/2 by 1/2. So remember, this is the width and this is the length. This is 1/2. And make sure that it's only from one part to the next part, just one square. One square. And since they told you that the section of the wall is 2.5 feet tall, from here to here, you want it to be 2.5 feet. Now, there's quite a few ways you could do that. You could say, how many times do we have to add to get 2.5? So if we do 1/2 plus 1/2, right now we have 1 whole, because 1 plus 1 is 2, 2 over 2 is 1. Now if we add another one, it would be 1.5. 1 plus 1 plus 1 is 3 over 2, and we want 2.5. If we convert 2.5 into an improper fraction, 2 times 2 is 4, plus 1, we're looking for 5 over 2. So far we only have 3 over 2. 1, 2, 3. We're going to go 4th time. And now we have 2 whole. It's not yet 5.5. It's not yet 2.5. Once we add one more, 1, 2, 3, 4, we're all set. I drew that a little bit too far, but right here. 1, 2, 3, 4, 5. 1 whole, 2 whole, and 1/2. 2 times 2 is 4, plus 1 is 5 over 2. All of this together is 5. So you should have, in terms of our rectangle, 5 squares going downward. Now we have to find out the width. I'm going to do the width on this side. We want the width to be 4.5, and each of them are 1/2. So we could keep adding 1/2 plus 1/2 until we got 4.5. A faster way to do that is just to find the improper fraction. 4 times 2 is 8, plus 1 is 9 over 2. And so we're going to need 9/2 to make 4.5. And you know, because this makes 1, 2, 3, 4, and 1/2. And that's 2, 4, 6, 8, 9. So we're going to need 9 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this should go 9 by 5. And all total, this should be 2.5 feet by 4.5 feet. That's part 8, just drawing the square. What is the area of the section of the wall? Keep in mind, what we're going to do is multiply the number of squares by the area of one square. So, if we're to count the squares, you could count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, blah, blah, blah. Or, since you're repeating 9 plus 9 plus 9 plus 9 plus 9 5 times, repeated addition, 9 plus 9 plus 9 plus 9 plus 9 is multiplication. You could do 9 times the amount of rows you have. 1, 2, 3, 4, 5. You could do 9 times 5, which is 45. So, the first step you do is multiply 45. Now you have to find the area of just one square. How do you find the area of just one square? You multiply the length by the width. So you multiply 1/2 by 1/2. Numerators are 1 times 1. Denominators are 2 by 2. So you multiply 45 by 1/4. Once you solve this answer, that will be your final answer. Numerators. Numerator 45 times 1 is 45, and denominators 1 times 4 is 4. And since the numerator is bigger than the denominator, we're going to know that the number is more than 1. 4 goes into 4 once. 4 times 1 is 4. Bring down the 5. 4 times 1 is 4. Minus is 1. Now the remainder, since we're not working with decimals, that's going to be our numerator, and the denominator is going to be the same. And so this is 11 1/4. And that right there is our final answer in terms of feet squared. So keep in mind, there are 45 squares, and then each square is 1/4. 1/2 times 1/2 is 1/4. So 45 times 1/4 gives you your answer of 11 1/4 square feet. So 2.5 feet times 4.5 feet give you 11 1/4 square feet. 2.5 total by 4.5 total give you 11 1/4. I'm going to start number 3 in a second. Go ahead and review that if you need to. Okay, now we're on number 3. A farmer's field has the dimensions shown. So we're using this figure right here. The width is 2 3/4 and the length is 1 3/4, both being kilometers. He needs to find the area of the field so that he knows how much seed to buy. Complete the area model below to find the area of the field. So we're trying to find out the area. And keep in mind that we can multiply this number by this number because either this is being repeated this many times or this number is being repeated this many times. That being said, we're going to take the one going up and down, the 1 1/3, and we're going to break it up, the mixed fraction into the whole number, 1. That's a silly looking one. And the mixed number, 1/3. And so I got the 1 1/3 from the mixed number right here, 1 1/3. We're also going to break up the width, the 2 3/4, by whole number, 2, and fraction 3/4. Now, we're going to find the area of each of these smaller sections, and then at the end we're going to add them all up. This is also the distributive property. The only difference is the distributive property doesn't really include the picture. And so if we're looking at the length here, it is 1, and the width of this portion is 2. 1 times 2 equals 2. Now I'm going to do this one. The length is still 1, and this time the width is 3/4. And so 1 times 3/4, anything times 1 remains the same. It's the same. So far we have 2, and we have 3/4. Keep in mind we're going to find all these little areas, and from there we're going to add them, all the numbers that we circled together. This one is going to be this small section right here, which is 1/3, times the width, and from here to here, it is 2. Keep in mind 2 is the same as 2 over 1, so we're going to multiply the numerator by the numerator, and the denominator by the denominator. And 2/3 cannot be simplified, so we're going to keep that answer. Now the last one is the trickiest one, and this corner is the one that most people typically make a mistake on, from what I've noticed and observed. So watch this one very carefully. This one is 1/3, and this one is 3/4. Now keep in mind we're multiplying the numerator 1 by the 3, and the denominator 3 times the 4. And the biggest mistake that I see people make within that one is just not multiplying the denominators. So remember, 3 times 4 is 12. And if we were to simplify that, 3 divided by 3 is 1. 12 divided by 3 is 4. So now we have 1, 2, 3, 4 numbers. And for these 4 sections, we're going to add them all up. I'm going to put my whole numbers over here on the side. 2, 3/4. I'm going to put that one with all the fractions. 2/3, and 1/4. Now, when we're adding, it is essential that the denominators are all the same. Keep in mind, when we're multiplying fractions, we could just multiply the numerator by the numerator and the denominator by the denominator, but since we're adding, we're going to have to find the common denominator. The common denominator is also the least common multiple, and so since our numbers are 3 and 4, we could list them out. Our multiples of 3 are 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, and so on. Our multiples of 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, and so on. The first number that they have in common is 12. There are no other numbers, but if there were, we take the smallest number, and in this case, it is 12. The 12 will be our new denominator. So to break it down, we looked at 4 and 3 because those are our denominators, and then we found the least common multiple. And then we put 12 as the denominator for all of them. Now you're looking at the arrow and asking yourself, how did the 4 become a 12? Well, you multiply it by 1, 2, 3. Multiply by 3. So as the numerator, you're going to do the same thing so that the number, these two can be equivalent fractions. 3 times 3 is 9. Likewise here, 3 times 4 is 12. 1, 2, 3, 4. And we're going to do that to the numerator. 2 times 4 is 8. Again, 4 times 1, 2, 3. 4 times 3 is 12. And we're going to do that to the numerator. 1 times 3 is 3. The reason why we multiplied this denominator and this numerator by 3 and this denominator and this numerator by 3 is because they both had a denominator of 4. This one was multiplied by a different number because they had a different denominator. And so keep in mind, it's how does the denominator get to 12? How does the denominator get to where it's supposed to be? And that's what you're going to repeat for the numerator. Now I'm going to add all these numbers up. 9 plus 8 plus 3. 9 plus 8 is 17, plus 3 is 20 over 12. And don't forget our whole number. 2 plus 0 plus 0 plus 0 is going to be a 2. Now when we look at 20 over 12, that's like saying if you imagine for a moment a pizza split into, pretend that this is 12. I'm not going to really cut it up, but pretend there's 12. You have 20 slices. So you have all 12 of these ones, and then you have some more slices. So what we're going to do is, we know that when the numerator is bigger than the denominator, the answer is going to be more than 1. So we're going to divide. with the numerator inside the house. 12 times what number gets close to or equal to 2? Nothing. Buddy, 12 times what number gets close to or equal to 20? Well, if you don't know, you can do it on the side. We know that 12 times 1 will be 12. Let's see what 12 times 2 will become. 2 times 2 is 4. 2 times 1 is 2. It's 24. You only have 20. Since 24 is more than 20, you can't do that one. You don't have enough. So you're going to use the math back 12 times 1. So, buddy, 12 times what number gets closer or equal to 20 without going over? 12 times 1 gets close to 20 without going over. And our remainder is 8. What happens to the remainder since we're not working with decimals? You could do a decimal and add a 0, but instead we're going to put a numerator 8 and a 12 will be our denominator, the outside number. Now all we have to do left is to simplify 1 and 8/12. You could divide 4 by top and bottom because you could see that it is both an 8 and 12 is a multiple of 4. So one whole number. 8 divided by 4 is 2. And 12 divided by 4 is 3. And so this 20 over 12 is actually 1 2/3. So this is 2, and 20 over 12 is 1 2/3. Don't forget this whole number 2. 2 plus 1 is 3 2/3 total. And that will be our final answer, 3 2/3 kilometers squared, or squared kilometers. Keep in mind it's length and width, so there's 2 dimensions, so you could say kilometers squared or square kilometers. Now we know that 2 3/4 times 1 1/3 equals 3 2/3. Good job. Okay, now we're on number 4. Stacy worked on her garden for 4 3/4 hours. So they told you specifically, without having to find an equation, how long Stacy worked. Stacy worked for 4 3/4 hours. Josh worked on his garden 2/3 times as long as Stacy. So in order to find out how long Josh worked, you'd have to solve that equation. 2/3 times as long as Stacy. Vicky worked on her garden 1 3/8 times as long as Stacy. Again, unlike Stacy, where they gave the specific number, in order to find Vicky's, you're going to have to do 1 3/8 times as long as Stacy's. So that's a mathematical equation. For numbers 2a through 2d, select true or false for each statement. Stacy worked longer on her garden than Josh worked on his garden. Well, we know how long Stacy worked. Stacy worked for 3 4/4 hours. That's a for sure thing. But Josh worked on his garden 2/3 times as long as Stacy. When we solve this, then we'll know how long whether Josh did more or less than Stacy. So, Josh spent 2/3 times as long as Stacy. So 2/3 times multiply sign, multiply, as long as Stacy. How long did Stacy go? 4 3/4. 4 3/4. So we're saying, will this equation, this will be less than, greater than, or equal to Stacy's 4 3/4. So this is exactly like one of those other lessons I remember posting, where we're not really concerned with solving the actual answer, but comparing less than 1, greater than 1, or equal to 1 to see whether or not the number is increasing or decreasing. So Stacy went for 4 3/4. Stacy went for 4 3/4, and Josh was 2/3 times that amount. When we look at the 2/3, we're thinking, is that less than 1, equal to 1, or greater than 1? If it's less than 1, then he worked less than Stacy, less than 4 3/4. If it's equal to 1, he worked the same amount as Stacy. They both worked for 3 4/4 hours. If it's more than 1, then he worked more than Stacy, more than 4 3/4. 2/3 is not a full amount. So he worked less than Stacy. So Josh, this is Josh's, will be less than, that is Stacy's. This is Josh because this is the equation, 2/3 times as long as Stacy's, and this is Stacy's. So Josh will be working less than Stacy. If you imagine this whole circle being 4 3/4, the whole amount of time that Stacy worked, he only did 2/3 of that. In other words, 0, 1, 2, 3, 4, 5. If Stacy worked 4 3/4, the number 4 3/4 is going to be between 4 and 5. 3/4 tells you it's going to be a little bit closer to the 5 than to the 4. This right here is how long Stacy worked. Josh only worked 2/3 of this. So remember, when we're drawing the number line, the number that we put an arrow underneath, that's what we're plotting on here. The number 4 3/4 is going to be between 4 and 5. And 3/4 is a little bit closer to the 5 than to the 4. So roughly around here. With this 4 3/4, that's how much Stacy worked. That's the arrow. Then we're going to take what Josh worked, which is 2/3 of that. We're going to split this into 3, because that's our denominator. And then we're going to color in 2 of them. Josh only worked for about this amount of time. Stacy worked for 4 3/4, whereas Josh only worked for roughly this amount of time. So Stacy worked longer on her garden than Josh worked on his garden. True. Josh spent less time on the garden. Stacy worked longer on the garden. So this right here is A. Now for B, Stacy spent less time working on her garden than Vicky spent on her garden. Well, we're going to do something very similar to what we did for A. For B now, we need to find out Vicky. Vicky worked on her garden 1 3/8 times as long as Stacy. If we take this into a mathematical equation, then we could be able to compare it. So 1 3/8 times as long as Stacy. Vicky did 1 3/8 times. Vicky worked 1 3/8 times as long as Stacy. And remember, Stacy worked for 4 3/4 hours. And we're going to see Vicky will be less than, greater than, or equal to Stacy's. And Stacy's again is 4 3/4. So this is Stacy. Vicky will be working less than, greater than, or equal to Stacy's. So this right here is Vicky's. 1 3/8 times as long as Stacy. And this right here is Stacy's. We're seeing if this will be less than, greater than, or equal to the original. Is 1 3/8 less than 1, equal to 1, or greater than 1? If it's less than 1, then Vicky spent less time than Stacy. If it's equal to 1, then Vicky and Stacy spent the same amount of time. If it's more than 1, then Vicky worked longer than Stacy. 1 3/8 is more than 1 because you have 1 and a fraction. Therefore, Vicky will be spending a greater amount of time than Stacy. Vicky will be spending a greater amount of time because it's 1 3/8. So, if Stacy spent 4 3/4, Vicky spent that one whole amount plus an extra amount. She spent 3/8 more. So you're adding. Hers is getting bigger. It's 4 3/4, whatever Stacy worked, plus even more because you're repeating it one and then some. So here, Stacy spent less time working on her garden than Vicky spent on her garden. True, because Vicky spent more time. Vicky will be greater than Stacy, so Stacy will be less than Vicky. True. The other ones, we could kind of use our logical reasoning to deduct. Josh worked longer on his garden than Vicky worked on her garden. Well, how about we put all of these people side by side? Who spent the least amount of time? Josh spent less than Stacy, and Stacy spent less time than Vicky. So the order is Josh spent the least amount of time. Stacy spent the next, because this is Josh's, that was Stacy's. And then Stacy, Vicky was more than Stacy. Vicky will be greater than Stacy. So this is the order. Now that we know the order, that Josh is the least, Stacy's is in the middle, and Vicky spent more than Stacy, we could kind of figure these two out by just using these two pictures. We don't need to create any more pictures. Josh worked longer on his garden than Vicky worked. Josh was the least amount of time, and Vicky was the most. So Josh worked longer than Vicky. That's false. And we can look at both of these pictures. We don't need to draw new ones. And then this chart that we made down here. Vicky worked longer on her garden than Stacy and Josh combined. Oh wow. Now we have to actually find specific numbers. Now we have to actually solve both of them to do this problem. So what we'd have to do is Stacy and Josh combined, add Stacy plus Josh, and see, did Vicky work longer on her garden than that answer? So we'll take Josh's amount, 2/3 times as much as Stacy, add it to Stacy's amount, 4 3/4, and then compare it to how long Vicky worked. So let's find Josh's here. Josh is 2/3 times 4 3/4. Just by looking at this, I'm going to need a new piece of paper. So I'm going to take one of these. Here's the back. Oh, this is going to be a long one. All right. Now, Josh is 2/3 times as long as Stacy. 2/3 times Stacy, and Stacy's 4 3/4. Josh is 2/3 times Stacy's. So let's solve this to find Josh's. 2/3. We're going to change this to an improper fraction by doing 4 times 4 plus 3. 4 times 4 is 16 plus 3 is 19 over 4. Then we're going to multiply the numerators by the denominators. 19 times 2 is 18, which is 38. 3 times 4, denominator times the denominator, is 12. When the numerator is bigger than the denominator, you could divide because the answer is more than 1. Buddy, 12 times what number gets close to 3 without going over? Nothing. 12 times what number gets close to 38? If you don't know, you have to do them on the side. 12 times 1 is 12. That's close to 38, but let's try a higher number. 12 times 2 is 24. That's getting closer to 38, but let's try an even higher number. 12 times 3 is 36. That's getting really close to 38. Oops. But let's try a higher number just in case. 12 times 4 is 48, and that's too much. We only have 38, and that's too high. So we're going to do 12 times 3. So, buddy, 12 times what number gets close to 38? 12 times 3, and that's 36. Keep in mind, because we're not doing denominators and shooting denominators straight up, the remainder will become our numerator, and the 12 remains as our denominator. So Josh worked 3 and 2/12, and we could simplify that a little bit farther because they're both even. You know they could divide by 2. 1, 6. So Josh worked for 3 1/6 hours. Let's look back to what the question was asking. We need to do Stacy and Josh combined. So we know Josh is 3 1/6. And we know that Stacy is 4 3/4. What we need to do is combine these two numbers. So let's add what Stacy did, 4 3/4. This is Stacy. And add it to Josh. And Josh is 3 1/6. Now, because they have different denominators, we cannot add them right away. We're going to have to do 4 3/4 plus 3 1/6 and find a common denominator. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 16, 20, 6, 12, 18, 24. They both have 12 and 24 in common, but we're going to take the smaller one, which is 12. And that, that will be our new denominator. We're going to ask ourselves, how do we get from this denominator to this denominator? 4 times 3 is 12, and if we did that to the bottom, the denominator will do that to the top, the numerator. 3 times 3 is 9. So we're mimicking whatever multiplication fact is at the bottom to the top. 6 times 2 for this denominator, so our numerator will be 1 times 2. 1 times 2 is 2. And from there we're going to add them up. 9 plus 2 is 11 over 12. And our numerators, our whole numbers, 4 plus 3 is 7 whole. The numerator is not bigger than the denominator, and there's no number to simplify. So, combined together, they worked 7 and 11/12 hours. So, combined together, they worked 7 and 11/12 hours. Let's look at the equation again. Vicky worked longer on her garden than Stacy and Josh combined. Stacy and Josh combined, 4 3/4 plus 3 1/6 is 7 and 11/12. If Vicky worked more than 7 11/12 answers, it is going to be true. If Vicky worked less than 7 11/12 hours, the answer is going to be false. If it is equal, then I guess it'll still be false. So let's find Vicky. Vicky worked on her garden 1 3/8 times as long as Stacy. So here's Vicky. Vicky worked on her garden 1 3/8 times as long as Stacy. Stacy worked for 4 3/4 hours. Keep in mind, if this answer is greater than 7 11/12, the answer is going to be true. So let's see. We're going to change these to improper fractions by doing 8 times 1 is 8, plus 3 is 11, 11 over 8. We're going to do 4 times 4 is 16, plus 3 is 19. And keep in mind the denominators are staying the same. From here, we're going to multiply the numerator by the numerator. 11 times 19. 9 times 1 is going to be 9. 9 times 1 is still 9. Don't forget your placeholder 0. So you take the first number and you multiply it by both factors. Now you're going to take the second number, don't forget your placeholder 0, and multiply it by both factors. They're not really factors, but 1 times 1 is 1. 1 times 1 is 1. 9, 10, 209. Then we multiply our denominators. 8 times 4 is 32. Because the numerator is bigger than the denominator, we're going to divide. Buddy, 32 times what number gets close to 2 without going over? Nothing. Buddy, 32 times what number gets close to 20 without going over? Buddy, 32 times what number gets close to 209 without going over? Let's try some numbers. 5 times 2 is 10. 5 times 3 is 15, plus 1 is 160. That's not quite to 209, so I'm going to change 5 to a higher number. Let's try 6. 6 times 2 is 18. Oh, that's 12. I don't know why I said 18. 6 times 2 is 12. Remove the 1. 6 times 3 is 18, plus 1 is 19. 192 is getting closer to 209, but let's try 7. 7 times 2 is 14. Remove the 1. 7 times 3 is 21, plus 1 is 22. Uh-oh, too much. So we're going to use 32 times what number gets close to 209 without going over? The answer is 6. 32 times 6 is 192. Oops. Sorry. The remainder becomes our numerator, and this stays as our denominator. And so our answer is 6 and 17 over 32 hours. That's how long Vicky worked. Vicky is 6 and 17 over 32. Vicky is 6 and 17 over 32 hours. So if Vicky is 6 and 17 over 32, and Stacy and Josh together 7 and 11 and 12 hours, 7 is larger than 6. Stacy and Josh combined is larger and bigger than Vicky. So this answer is false. That was quite a few steps to get to D. Okay, for the last one, Jessica rides the bus 8 4/5 miles each day. Which statements correctly describe how far she rides the bus? Mark all that apply. Mark all that apply means you have to try A, B, C, and D. If Jessica rides the bus 35 1/5 miles in 4 days, then you're going to multiply. She's saying that this is how much they do each day. What you have to do is keep in mind, imagine this being 1 day. 8 4/5 is how much they do in 1 day. So if we're talking about 4 days here, we're talking about 1, 2, 3, 4. If you do 8 4/5 miles 1 day, 2 days, 3 days, 4 days, you're repeating 8 4/5, 8 4/5, 8 4/5, 8 4/5, adding blank, blank, blank. So instead, a faster way would be 8 4/5 times 4, because what is a repeated addition? It's multiplication. If this answer you get is 35 1/5, the answer is true and you're going to circle it. Or you're going to circle that in. If this equation does not become 35 1/5, then it doesn't work and you're going to put an X on it. So solve this equation. If it's 35 1/5, circle it. If it's not, you could X it out. Likewise, let's try 7 days. Instead of it just being 4, you'll have 5, 6, 7. And so your equation will be 8 4/5. This right here is a 5, okay? Times it by 7 days now. If this answer is 61 4/5, then you circle it in, because that's true. If 8 4/5 times 7 is not equal to that, then you'll cross it out, because it's false. Likewise, what do you think the equation will be here? 8 4/5, it's being repeated. How many times? 10. 8 4/5 is being repeated 10 times. If this answer is 88, you're going to circle it. If it's not, you're going to exit out. Lastly, 25. 8 4/5 is the number we're repeating each day, and it's being repeated 25 times. If this answer is 218 2/5, you circle it. If not, you're going to exit out. And keep in mind that the first step is going to be changing this to an improper fraction, putting these numbers over the number 1, multiplying the numerators and then the denominators. This one I won't be solving for you. However, we can go over it during class if you like. But I did want to at least set it up for you. I will be giving the answers out during class, but for now I'm going to end the video here. Have a good day.